Here I'm going to describe a new way of verifying frequency shifting in hearing aids that only adds a minute or so to your fitting. The first thing you will need is an audio extension cord that will be used to connect the headphone jack from the VeriFit to the microphone jack of your computer. The length of the cord you will need will depend upon how far apart those two are. A 6-foot cord will generally run for under $5, and you can pick that up at Radio Shack. The other thing you will need is a specially developed signal I've created, and that can be downloaded from my website at the address below. You will plug one end of the extension cord into the monitoring headphone output jack on the VeriFit. Next to the headphone jack, you will see a volume wheel. If you roll it down, you are increasing the volume that's being sent to the computer. If you roll it up, you're decreasing the volume. And what you're going to want to do is watch your recording and adjust the volume to make sure that you are not peak clipping. Then you want to plug the other end of the extension cord into the microphone jack of your computer. The next thing you want to do is connect the hearing aid to the 2cc coupler and put it in the test box. And all you need to select in VeriFit is test box mode. You don't need to select speech live or anything like that. And once you do this, it will automatically be playing out from the headphone jack. And then what you want to do is place the computer speaker about 12 to 18 inches from the hearing aid microphones. What makes all of this possible is the way that the test signal has been created. The test signal is only 10 seconds long and consists of 100 AM/FM modulated tones that ascend in frequency at a rate of 100 Hz for every 100 milliseconds. This allows us to view the recorded signal in a traditional spectrogram using the time axis as a frequency axis, where we can substitute hertz for milliseconds or kilohertz for seconds. This gives us an input base for the frequencies that are entering into the hearing aid. And then using Audacity, an open source program, we can go ahead and play the signal at the same time that it is recorded. Then both signals together can be exported as a typical WAV file, and this will allow us to view both signals at the same time, where we can see the output signal and how it's changing frequency as a function of the original input signal. I do recommend for the transposition device that you may want to export the recorded signal only, because the output signal already consists of the untransposed signal.